Hello friends, in this video we will learn about water. Water is the medium of life. As we all know, life originated in water. Long ago, in water of sea, there originated a cell, the first living organism. In the beginning, only unicellular organisms appeared. Later, as time passed by, multicellular organisms started appearing. Eventually, more complex creatures came into existence. Today, we have came out of water and living on the land, but the cell in the body are in environment as if they are still in sea water. These are the cells surrounded by extracellular fluid. The composition of extracellular fluid still resembles the sea water. It is rich in salt, that is NaCl. It looks like inside the skin there is an ocean and all the cells are still living in that ocean. So, water is the medium of life. Next question, why water? Because water has certain properties which makes it a good candidate for being the medium of life. First, it maintains the liquid state over a wide range of temperature found on earth. And second, it is a good solvent. Now let's see the structure of water and understand why water has these properties. This is a water molecule. It has two hydrogen atoms bound to one oxygen atom. This type of shape is because of distribution of electrons around the nucleus of central oxygen atom. Oxygen has 4 electron pairs surrounding the nucleus which are arranged roughly in the form of tetrahedron. This is tetrahedral shape. Each of 4 electron pairs are directed towards each corner of tetrahedron. Out of 4, these 2 electron pairs are shared with hydrogen atom and these 2 pairs are unshared. Thus, the molecule of water is angled rather than being in straight line. The HOH angle being 104.5. Now, oxygen attracts shared electrons more strongly than hydrogen atoms. So, these electron pairs are more close to nucleus of oxygen than the nucleus of hydrogen. This creates slight negative charge on oxygen atom and slight positive charge on hydrogen atom. Thus, an electric dipole is created across the water molecule. Because of this, hydrogen atom of one water molecule and oxygen atom of adjacent water molecule are attracted towards each other. This bond is called hydrogen bond. Because of the tetrahedral arrangement of electron around oxygen nucleus, one water molecule can have as many as 4 hydrogen bonds. But all 4 hydrogen bonds are seen only in solid state of water, that is ice. When in liquid state, water molecules are continuously in random motion, so hydrogen bonds are continuously forming and breaking. How does that happen? To see, we will trace random motion and hydrogen bonds of this water molecule. Let's start. So you see that while moving, water molecules forms hydrogen bond with one molecule for some time and bond breaks and new bond is formed with other water molecule. Now the lifetime of each bond is about 1 to 20 picoseconds. You can also see that because of this random motion, one water molecule does not have all 4 hydrogen bonds at a time. Like here it has only 3 hydrogen bonds. Now look at this position. Here it has 4 hydrogen bonds. So while in random motion, the number of hydrogen bonds keep changing for a molecule, but for an average, each water molecule is bound to 3.4 other molecules. Now, an individual hydrogen bond is very weak, but all hydrogen bonds in water combined provide strong cohesion between water molecules. This is responsible for higher boiling point of water, and water does not boil even at extreme temperature of deserts. Now let's see what happens in ice. As the temperature decreases, random motion of water molecules also decreases, and as water freezes completely, there is no motion in water molecules and they are arranged in a regular lattice structure where one water molecule is connected with 4 adjacent water molecules. For example, look at this molecule. It has all 4 hydrogen bonds. Like this, all the water molecules has 4 hydrogen bonds. When in liquid state, one molecule has only 3.4 hydrogen bonds, while in ice it has 4 hydrogen bonds. Thus, number of hydrogen bonds are more in solid state, and in fact, it is these extra bonds that stabilizes water and converts it from liquid to solid. And if we want to convert ice back to liquid water, we need to break these extra bonds only. Important point about the lattice structure is that the same number of water molecules occupies more space in this lattice structure than in liquid state. So ice floats on water. In areas of extreme cold temperature, this floating ice works as an insulator and prevents further freezing of deeper water where aquatic organisms can still live. Now let's see properties of water as a solvent. Charged substances are soluble in water and uncharged substances are insoluble in water. Why so? Let's see. First, let's take a molecule XYZ with charged atom. We don't bother about the rest of the structure of the solute. What is more important for us right now is the charged atom. So I have only shown a charged atom separately. Now let's see what happens when we mix it with water. In the solution, solutes interfere with hydrogen atoms between water molecules, but this is compensated by forming hydrogen bonds with the charged groups of solute in more or less the same way as with other water molecules. So, charged substances does not introduce significant changes in water. So, charged substances are soluble in water. Now, let's take a substance with no charges on it and mix it with water. Having no charges on it, water molecules cannot form hydrogen bond with it. Because of that, water molecules in immediate surrounding of it has reduced possibility of forming hydrogen bond. For example, if this water molecule while in random motion comes in this orientation, directing this hydrogen atom towards uncharged molecule, it can no longer make hydrogen bond at this hydrogen atom. Same is true for this and this orientation. Well, this and this orientation should also be mentioned because possibility of hydrogen bond are here also. So now, to maximize the chances of forming hydrogen bonds with other water molecules, this molecule will not get oriented in positions I just mentioned. In fact, it gets oriented in such a way that hydrogen bonding vectors are as tangential to the uncharged molecules as possible, like this or this. The moral of the story is that the uncharged molecules reduces random motion and induces ordering of water molecules. Similarly, the random motion of all other water molecules in immediate surrounding of these uncharged molecules also decreases and they form a cage around the molecule. Thus, uncharged molecules increases ordering of water molecule, or in other words, decreases entropy. Now we know from chemistry that all systems tend to go towards decreasing order or increasing entropy or increasing randomness. All are the same thing. So here also something happens that allows as many water molecules to be in random motion as possible. What happens is uncharged molecules cluster together. So the total surface area of uncharged molecules decreases and less number of water molecules are ordered around the cluster and more water molecules can move randomly. Thus, uncharged substances are not soluble in water. And when we mix them in water, molecules tend to cluster together as if the non-polar molecules had some net attraction for one another. This apparent affinity of uncharged structure for one another is called hydrophobic interaction. Actually, this apparent extra attraction between uncharged solutes is an entropy-driven process due to a net decrease in ordering among H2O molecules. These hydrophobic interactions are important in forming biological membrane. So that's it for water. Thank you.